The contact information and office hours are published on Canvas in the Syllabus section. Please refer to the official Syllabus document for more details. Please contact me as soon as possible about any unanswered questions or concerns. This course has significant blended component, where most of the theoretical material and quizzes will be given online. For that reason, we have only one weekly meeting. You should come to those meetings prepared with theoretical knowledge from Canvas published video lectures. The first objective of this course is that the material you learn will be still useful and relevant for your work or research in at least 5 or 10 years from now. The second objective is to prepare you for self-learning and updating your knowledge from technical sources. This will allow you always to stay current in your field and not to get fired. The third, more ambitious and optional objective is to prepare you for a graduate level work on signals and systems. I don't want you to spend money on textbooks, because video lectures and written summaries should be sufficient. Nevertheless, many good textbooks exist, and you could read my online recommendations for choosing the right book for you. The grade consists of 4 components. Online quizzes will be 30%. Simulation lab projects will be 25%. The first test, 20%. And comprehensive second test, 25%. Online quizzes are available on Canvas. Note that some of those quizzes are embedded into videos, so you have to watch the video to answer the questions. For all quizzes, you have infinite number of attempts, so everybody could get at least 30% in this course if being persistent enough. Clearly, it is possible to guess the correct combination of answers by trial and error, but please don't do it to yourself. First, tests will have similar questions, and second, if you are missing some important pieces of the puzzle now, it will be difficult for you to recover and see the entire picture later. The lab component will be mostly MATLAB based, where following the instructions you will need to replicate some signal processing and analysis results in various experiments. We will use simulation as the main tool for demonstrating principles of signals and systems. MATLAB is our language of choice, because it is easy to learn and work with. You must install the latest version of MATLAB. It is free for you as a UB student. Please contact Help Desk for any installation issues. They can help you with that. I will assume that you have already some basic MATLAB knowledge. Learning to use simulations is not only important for education. It is helpful in industrial settings. Software and hardware prototyping is costly and consuming significant time. Mathematical modeling for signals and systems helps to explore designs and helps to build the projects. One late submission is permitted without penalty. Additional late submissions grades will be automatically divided by 2, unless excused by me or medical official. The tests will have multiple choice conceptual questions and open questions. Test questions will be very similar to questions solved in online quizzes and in the class. I was always a big proponent of open materials for all tests, and sometimes even allowed laptops with internet connection. Unfortunately, research and my own experience show that many students use it against themselves. They hope to learn the material at the time of the test, and hope to find answers in the textbook instead of thinking. So, in this course, at the test time, you will be given standard printed formulae pages, and you could bring with you any materials written with your handwriting. You will submit those handwritten pages with a test. No textbooks or any other printed material is allowed. Also, you could bring to the test non-graphical calculator. If you have a special need or particular circumstance that may have an impact upon your work in this class, please contact me early in the semester, so that we can work together to adapt assignments to meet both your needs and the requirements of the course. The basic list of topics in this course includes signal classification, Fourier series and transform, system properties, Laplace transform, filters, and Z-transform. But we will go above and beyond those, learning about control systems, sound effects, radio, biomedical signal analysis, and so on. Learning signals and systems is important for understanding control systems and estimation, communication systems, random processes, machine learning, computer vision, analog circuit design, power systems, biomedical signals and image analysis, robotics, and others. Generally speaking, this course is designed for three types of learners: those who just want to pass the course and tests and forget it. Another type, those who want to understand the material. And third one, those who not only want to understand the material but also consider doing research or engineering projects in the area of signals and systems. I will not penalize you on any of those three choices, but you all will have to pass minimal requirements to get a good grade. For those of you who are interested in learning more, you will find sections marked as optional. There you will learn things that I believe are more interesting and practical. You will have also opportunities to apply your knowledge in state-of-the-art research. How to complete successfully this course? You need to learn techniques, but even more importantly, you should try to understand what you are doing and why. Do all homework. Come to all lectures and write as much as you can. Always ask questions if something is not clear. Remember that questions cannot be silly, only answers can be. Sometimes lecturers, including myself, become arrogant or condescending when answering questions. This is because the question is good and we don't know how to answer it well. And as all humans, we don't like to feel embarrassed. Please don't worry about that. In this course, asking any questions will play only in your favor. I promise to make an effort to find out the answers for you if I don't have them yet. Use MATLAB frequently to check all of your theoretical computations and always apply common sense. If the output voltage of your electronic circuit equals 1 million volts, your answer is wrong even if you confirmed your computation with MATLAB.